Hello everybody, welcome to Homework Helper for section 3.5. We're coming off of a long weekend, so we're a little rusty, but I think this little bit of math support can kind of help with some of the questions we've been having. Let's start with these first questions. It says for each function, find the indicated value. So what this is really relying on us understanding is the idea of function notation. And that means back in the day we would say y equals, like mx plus b. But now what we're doing is we're doing an f of x equals mx plus b, where f of x replaces the y. So when we look at our given example here, it tells us h of t equals 2t minus 5. And then it asks us to find h of negative 4. So h of negative 4, you can see exactly what we did here. Instead of writing a t, we wrote a negative 4. Let me try to zoom this in a little bit. Okay. So instead of writing t, we wrote negative 4. So that means on this other side of the equation, on the right side of the equation, we're going to do the same thing. Instead of writing t, we're going to write negative 4. So this means, just like this is 2 times t, this is 2 times negative 4, which is negative 8. And then negative 8 minus 5 is going to be negative 13. So I know that that's going to be negative 13. It then asks us to do something similar but kind of different. This time it tells us h of t equals 23. And it wonders what t makes that true. So that means there's some number we can plug in here that would give us 23. So we've got to figure out what that is. So what I'm going to do here is instead of writing h of t, I'm going to write 23 equals 2t minus 5. And all I did was I took that h of t and I plugged in 23 for it. And so now I just need to solve for t. I add 5 to both sides. I add 5. I get 28 equals 2t. I divide by 2. Divide by 2. And so I get 14 equals t. Right? So that would be my answer, 14. Cool. So that's how we do those. Now let's go ahead and zoom out. And it'll ask us to do it for a couple of graphs, and then we just have to find it graphically. But here, let's look at the directions. Adding functions. So this is what we kind of focused on today with the pool example. Here it asks, the two functions are graphed. Graph a new function on the same grid by adding the two given functions. All right. So for number 4, we have f of x plus g of x. So when we add these, what we're going to be doing is we're going to be looking at what values they are at and then adding them accordingly. So I look here first. This looks super easy to spot. This is at 0, this is at 2. So when I add them together, 0 plus 2 is 2. So that's what my h of x is going to be. Let me go to 2 here. When I go to 2, I see that I'm at a negative 2, and this looks like it's halfway. This looks like it's 3. So negative 2 plus 3 is going to be 1. So that's going to be right there. I'll then go to 4. This appears to be 4, and this appears to be negative 4. 4 plus negative 4 is 0. So they cross right there. Right? Now let me do this for negative 2. At negative 2, I have 1 and 2. 1 plus 2 is 3, or about right there. And you can kind of see this is what our line will start to look like. Just like that. All right. So then we have one more section we need to cover. Let me see if I can find it. There we go. Finally, with just a little bit of review, where we're looking at distinguishing between discrete and continuous. Susan puts exactly $5 a week into her piggy bank. This is one of the classic examples where we know it's discrete. And one of the things that I really want to make sure we understand is that when we have dots like this, that is discrete. And when we have lines that are touching all over the place, that's going to be continuous. So just kind of keep that in mind and refer to some of those older videos. All right, that's going to be it for this week. Answer the questions the best you can, and if you have any questions, come and see me tomorrow.